YouTube channel. In this video, I'll be discussing about the proof of the sum and difference identities. However, before you watch any further, don't forget to hit the subscribe button so you won't miss any of my videos. And if you do enjoy this video, don't forget to hit the like button and share this link to your friends. In my previous videos, I've shown you about 6 of the sum and difference identities. And they are the sine of a plus b, sine of a minus b, cosine a plus b, and the cosine of a minus b. And also we have our tangent, both of them. However, as I said in the previous video, this equation is very hairy, and it seems that this equation does not come into mind directly. And how will we get that, the proof of it? Well then, in this video, I'll be discussing about the proof of it. However, because there are a lot of different types of the sum and difference identities, this time I'm just going to use this cosine first. I'm going to prove this one first. So then we know that cosine of a plus b is going to be cosine of a times by cosine of b minus by sine of a times by sine of b. So then, to prove the cosine of a minus b, we firstly have to prove cosine of a plus b. So then, first let's take out our single radius circle, and it's called the single radius circle or the one radius circle because it is a circle located at the center or the origin of the Cartesian plane and has a radius of 1. So then, let's just name this dot over here as, let's say, C, and then let's call it 0, 0, because that's going to be its coordinate. And then this point, let's just call it D, is going to be 1, 0 for its coordinates. And then, I'm going to draw in an angle. Okay, so let's say that it goes up until here. And this angle, let's call it as angle A. So then, we will have this dot right over here that we get from intersecting our line and the circle. And let's just call it as A, because we have our angle A, so let's call this dot over here as A. And then, for the coordinate, it's going to be, using our trig ratios, we can know it's going to be cosine of A, comma, sine of A. And then, let's make ourselves another angle. Let's say it's gonna go right over here. And let's say that it overlaps with our angle A. So this total angle is going to be angle B, because it overlaps with our angle A. Then let's call this one, this dot over here is B. And then for its coordinate, it's gonna be cosine of B, comma, sine of B. And then, what about sine of B minus A? So, for that, let's just draw another angle. And in this angle, it, again, overlaps with our A and B. So it's going to go from this point, let's just call it as E. It's going to go from this point up to the center, which is C, and then hitting into this point, D. So it overlaps. So this is going to be, so then the point in the coordinates is going to be cosine of A minus B, comma, sine of A minus B. Okay, and then there are two ways to draw the angle B minus A. First, we can make it overlap with our angle B and A. The second, we make it overlap with B but doesn't overlap with A. So the first one, it goes from this E, C, and D, or B, C, A. So it goes this angle. So then, let's just draw a line that connects those two dots. So first one is here, from E up to D. Let's just make it in here. And then, it's going to be called a chord, which is basically a line segment that connects 2 points in a circle. And then let's just make another chord with another angle of B minus A. And then because these two angles, the one I drew the chord of, have the same angle. They're going to have the same line. So then we can say that chord AB is going to be equal to chord ED. And then, so how will we find the distance of the chord? Well then, we're going to use the distance formula. And then, we can notice that it's going to be square root of, from A to B, there's going to be cosine of A minus by cosine of B squared plus by sine of A minus by sine of B quantity squared. So that's basically the derivation of our chord AB. And then for our chord DE, it's going to be the same thing. It's going to be square root, and then it's going to be cosine of A minus B minus by 1 squared plus by sine of A minus B minus 0 squared. And then we can further derive this, of course, with algebra. And then let's just erase these square roots. So it's going to be, the first one is cosine of A minus cosine of B squared. We can make it and FOIL it out as cosine squared of A plus by cosine squared of B minus by 2 cosine of A cosine of B. And if you're asking, how did we find this? Well, let's just take this expression, cosine of A minus cosine of B squared. And then, let's say that cosine of A is A and cosine of B is marked as B. We can simplify this into A minus B squared. And we know that this is equal to A squared plus B squared minus 2AB. And then we fill in A as cosine of A, B as cosine of B, and it's going to be this expression over here. So we'll just erase this. And then we can put our sine of A minus sine of B squared. We just use the same formula. It's going to be plus by sine squared of A plus by sine squared of B minus by 2 sine A sine B. And then for this expression, we can also use the same way. It's going to be equal to cosine squared of A minus B, and then we're going to plus by 1 squared, which we can simplify as 1 only. And then we're going to put minus by 2 cosine of A minus B. That's going to be this expression over here. And then this one, this is going to be, well, because sine of A minus B minus 0 is basically sine of A minus B. And then we square it, it's going to be sine squared of A minus B. And then we can put in some algebra. But first, we know about the Pythagorean identity, that sine squared plus by cosine squared is equal to 1. And then, let's just see. First, we have cosine squared of A. We can pair it with sine squared of A, and that would be 1. So we can erase that one and erase this one. And then, cosine squared of B, we can also pair it with sine squared of B. And it's going to be cancelled out into 1. And 1 plus 1 is 2. So it's going to be 2 minus by 2 cosine A cosine B, 2 cosine A cosine B. And then put our minus 2 sine A sine B, minus 2 sine A sine B. And then we put in this one. Well, we can also use our Pythagorean identity, cosine squared of A minus B with our sine squared of A minus B. It's going to cancel out. So it's going to be equal to 1 minus 2 cosine of A minus B. But we add our 1 from this Pythagorean identity. So it's going to be 2 minus by 2 cosine of A minus B. And then in here, we're almost going into there. And then let's just minus both sides by 2. Let's just minus both sides by 2. And then these 2 will cancel out. And same thing in here. And then let's just times it by -1. So everything negative will be positive. And everything positive will be negative. So this negative will make this negative into a positive. Same thing with this one and this one. So it's gonna be 2 cosine A cosine B. So let me just erase this one over here. So it's going to have more space. So it's gonna be equal to 2 cosine of A cosine of B plus by 2 sine A sine B is equal to 2 cosine of A minus B. And then we can divide both sides by 2. And then we're going to get these 2 cancels out. Same thing here and in here. We're going to get cosine of A minus B. Cosine of A minus B is going to be equal to cosine of A times cosine of B plus sine of A times sine of B. And there you go. That's the proof of our law of cosines, but that's only cosine of A minus B. So then, let's use this to solve for cosine of A plus B. Although, we can at first solve for cosine of A plus B, then solve for cosine of A minus B. So first, let me just erase this place. So we're going to get more space to work with. But I'm not going to erase this one, because we're going to need it. So then, we can always recall that cosine of A plus B is equal to cosine of A minus by negative B. So then, to get our cosine of A plus B out of this one, we can just change our B into negative B. So then, it's going to be cosine of A minus B. So it's going to be A minus negative B. So it's going to be A plus B. That is going to be equal to cosine of A times by cosine of negative B. And also, we know that cosine of negative B is equal to cosine of B. And then, it's going to be cosine of A times by cosine of B. And then, sine of A times sine of B. It's going to be sine of A is basically sine of A because it's not changed, but sine of B. So what is sine of negative B? Is it equal to sine of B? Well, sine of negative B, is going to be negative sine B. So this is going to be negative sine B. So sine of A times by negative sine of B is going to be minus sine of A times by sine of B. And there you go. We've also proven our cosine of A plus B. And also, if you enjoyed this video, don't forget to hit the like button and share this link to your friends. And also, if you're asking, what about the sine and tangent? Well, it's going to be a part of my next video. Thank you for watching.